Hello everybody, welcome back. It's time to get into puzzle solving mode. We have spent a few classes on developing some concepts and techniques for calculating angles, and today we will start applying these techniques in more complicated figures. So this is not just about understanding rules, it's also about problem solving strategies. So I'll briefly say something first about how I think you can best approach these problems, and then we will look at an example together. When solving puzzles, you will have to be aware of what you know. You have to know the rules, of course, but you have to be able to do slightly more than that. You have to be able to access them quickly and decide whether they apply. For example, as soon as you see a right angle, you should think, maybe I can use the fact that this adds up to 90 degrees. Or as soon as you see two equal sides in a triangle, you should think, this is an isosceles triangle, so there will be equal base angles. That doesn't mean that you have to see the entire solution at one glance, and usually you will not. What I often find very useful is to work backwards from the question. They want me to calculate this, so what do I need to know in order to get there? Once I see that I have a path to the solution, I start writing down my steps. I'll need to justify those steps, which means that I mention briefly which rules I used. Let's look at an example. We have this figure, and the question is, can we calculate angle B2? I don't immediately see the solution, but I can ask myself, what do I need to know in order to be able to calculate angle B2? And I see that B2 here is part of a straight angle together with angle B1. So that means if I would know B1, if I knew B1, then I would be able to calculate B2. So that changes the question basically into, can I calculate angle B1? And that means that I can ask myself, what do I know about angle B1? Is there anything that can help me calculate angle B1? Well, B1 is in a triangle. That could be useful. Even better, it's in an isosceles triangle, because I see that AB and BC have the same length. And in an isosceles triangle, as soon as I know one of the angles, I know all of the angles. So I would have to know either angle A1 or angle C in order to be able to calculate B1. So do I know how to calculate A1 or to calculate C? Well, A1 forms a straight angle together with A2, and I know A2. So that's enough. A2 is going to help me to calculate A1. A1 is going to help me to calculate B1, and then B1 is going to help me to calculate B2. Now that I know my path, I'm going to write this down step by step. So first, A1. A1 and 2 are a straight angle, so I use that as a rule. I write down that angle A1 is 180 degrees minus 138, because it's a straight angle. So that means that A1 is 42 degrees. Now I am going to calculate in this isosceles triangle. I see that this is one of the base angles. So I know the other base angle. I know angle C. That equals angle A1. So that's 42 degrees because of them being base angles of an isosceles triangle. And now I know 2 out of 3 angles in this triangle. So I can use the angle sum rule to calculate angle B1. It's going to be 180 minus 42 equals 96 degrees. And now, now that I know B1, I can calculate B2, because B2 is going to be 180 minus 96 is 84 degrees, because both form a straight line, so they are a straight angle, singular. And that's my answer, 84 degrees. Now, coming up is the solution to one of the exercises in your textbook, exercise 33. And as always, don't watch that part before you've tried to solve the homework exercises by yourself. Just come back to it if you need to. And one more thing, this is, I think, one of the hardest parts of the chapter, but I think it can also be one of the most satisfying. It combines geometrical intuition with careful reasoning and using numbers to solve puzzles, and I hope you will come to agree with me that is not just interesting and challenging, but also actually quite fun to do. So I wish you good luck with the puzzles, and see you next time. And let's take a look at this exercise 33. We see, they tell us that CD is the bisector in this shape of angle C. And the way they show us that is by giving us these two dots. That means that these two angles, C1 and 2, are equal. There's some other information. These two sides in this triangle are equal. So we have an isosceles triangle where the base angles will be the same. And we know one angle here. The question is, can we calculate angle D2? When would I know angle D2? Well, I would know it if I know either angle D1 or angle D3, which will be the same, of course. They are vertically opposite angles. If I know one of them, then I will have a straight angle, and I can calculate angle D2 using that. The most promising here will probably be angle D1 because it's in this isosceles triangle, and that means I would have to know only one other angle. In angle D3, I also have a triangle where I know one other angle, but it's not isosceles, so I don't have enough information. But this would be promising. I would know D1 as soon as I know either A or C1. Well, C1, they've told us, is equal to C2. So if I know C2, then I know C1. And now I'm getting close because C2 is in a triangle where I already know an angle, 48 degrees here, and I know this angle here at G because it is a right angle. This is right, so this is also going to be a right angle because together they are a straight angle. So here's my path. I'm going to use this triangle to calculate angle C2. That gives me C1, that will give me D1, and that will give me D2. Now, let's do this step by step. Angle G is a right angle, so let's say explicitly that it is 90 degrees. And now we can use that to calculate C2. C2 will be angle sum 180 minus this 90 minus 48 is 42 degrees. C1 is the same. That's given, so we don't have to justify that, but we could say it's that CD is the bisector of angle C. Now we know C1. C1 is the vertex angle, so the other two angles are the same, and the sum of the other two angles is going to be 138. 180 minus 42 is 138. So A and D1 together are 138. Angle A plus angle D1 will be 138. And both of them will be half of this 138 because they are the base angles of an isosceles triangle. So angle D1 will be 138 divided by 2 is 69 degrees. And if I know that D1 is 69 degrees, then D2 will be 180 minus 69 is 111. Is that right? 69, 70, yes, will be 111 degrees because D1 and D2 together are a straight angle. And that's our answer.